are from Group 2-1 doing Experiment 5, Cavitation. So, cavitation is the formation of an empty space within a fluid. So one of the main disadvantages of cavitation is the production of noise and vibration, which in turn leads to machinery damage. One of the main advantage of cavitation is that it can be used to enhance chemical reaction.
Hi, today I am going to introduce about the cavitation bench apparatus. Firstly, this is the water tank and there is a thermometer inside the water tank to measure the temperature of the water. Next will be the pump, and then this is the rotameter. Rotameter is used to read the flow rate of the water. Next is the switch for power on and off it. This is the valve. Valve is used to regulate the flow rate, and here is the venturi meter. There's two meters. This first meter is the inlet pressure indicator, which is the P1, and this is throat pressure indicator, which is the P2.
Hi, I'm going to explain the procedures for this experiment. Here is the water tank. Inside the water tank, there's a thermometer. This thermometer is used to measure the water temperature, and here you can see the recording is 23 degrees Celsius. Ensure the valve is closed before turning on the pump. Here is the power button. You switch on the pump, and then you turn the valve to regulate the flow rate. In this experiment, we regulate the flow rate to 3000 liters per hour. After the rotameter shows the reading of 3000 liters per hour, we record the inlet pressure here and the throat pressure here.
Now I'm going to talk about the calculation used in this experiment. First, we must find the velocity for each flow rate by using the formula Q1 equals to A1 V1, where Q1 is the inlet flow rate and A1 is the area of the venturi at the inlet. And then we can find the value of the resistance coefficient and vapor pressure or P2 by plotting a graph based on the linear equation P1 equals to K star 1 over 2 rho V1 squared plus PV, where K star is the gradient and PV is the y-intercept. As for rho, the density of the liquid at 23 degrees Celsius is 997.6 kg per meter cube. After plotting the graph, we can see that the value of K star is 70,000 and the value of vapor pressure or PV is 10 kilopascal. Now, with the K star value, we can find the experimental value of the resistance of coefficient of venturi or K venturi by using the formula K star equals to 4.83 plus K venturi, where K venturi is equals to 69,995.70. And then we can find the theoretical value of K venturi by first finding the friction loss by using the Bernoulli equation. After calculating the friction loss, we can now put the value into the formula F equals to K venturi times V squared over 2, where V is the average velocity. And then we will get the value of K venturi is equals to negative 13.127.